Hey folks, today's topic, creating functions given domain and range. So I think one of the most powerful ideas in mathematics is that once you figure out how to do something in one direction, to show that you really understand what you're doing, you should be able to do it in reverse. And that's what today's topic is. What we're looking at here is the reverse of what we did here. So it's actually a combination of a couple different things. It's this one and these notes. So if you want to get back some notes that if you want to do some reviewing, if what we're doing today sounds really confusing, you might need to go back and look at the 1.6 and 1.8 notes. So what we're trying to do is I'm giving you what we did in 1.8 was I gave you the function. We transformed that function doing 1.6. So we did our shifts. Remember that anything with X does the opposite of what it says. Anything not with X is Y and does the same. We have this value out front that plays two roles. It'll tell you if your graph is reflected or not, and it will tell you if your graph is a stretch, shrink, or neither. So what we did in 1.8, I gave you the equation. We transformed it, sketched it, and then we looked at how far does it go on the X and how far does it go on the Y, and then we answered with a domain and range. Today's topic is the reverse. I'm giving you a domain and range, and you have to come up with a function that has this domain and range. And it seems a little bit intimidating at first, but if you break it down, it's actually not too bad, especially if you have this sheet, our parent functions sheet. This will really help you be able to decide the functions based on their domain and range. So let's go through and kind of make a little list. There is no perfect way to do this, but I found that these couple of steps usually help out. Number one, sketch the domain and range. So I'm first going to make a little sketch of this domain and range like we did after drawing the graph. So I'm going to draw these little lines in here, and I'm going to use those lines to help me decide which family of functions to use. So sketch the domain and range. Number two, find the function family that matches. And like I said, when we do an example, this will make more sense. But if you have a graph that has domain is all the way left and all the way right, I'm going to try to find one of these graphs that also goes all the way left and all the way right. It's going to narrow down my function families. Then number three, once you figure out your function family, decide if you need a negative. In other words, does your graph reflect? And then finally, number four, decide if you need a shift. So those of you who really understood, who really got how to transform our parent functions, this will be pretty easy for you, I think. Those who struggled with this, what's nice is you get a chance to relearn this because it applies it in the reverse direction, but it might take you a little bit longer. All right, so let's take a look here. I'm going to first sketch my domain and range. So I'm just going to draw a little coordinate plane. And then I'm going to draw all my domain and ranges in the same color. So my domain is negative infinity to infinity. My range is negative infinity to infinity. So my graph's going to go all the way up, all the way down, all the way left, all the way right. Now I'm going to compare it to my function families. Let's look at the quadratic family. Does that go all the way left and all the way right? Yes, right? The graph gets wider and wider and wider. Does it go all the way up and all the way down? No. This graph only points in one direction. So that's right away we can eliminate. Does this graph, do cubics go all the way left and all the way right? Yes, this graph keeps going wide, 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 and wide, wide, wide. Does this graph go all the way up and all the way down? Yes. Okay, so that's a function family that would work. Let's check to see if any other ones would. All the way left and right? Yes. All the way up and down? No. Only points in one direction. All the way left and right? No. Only points in one direction. Also, only points in one direction in the y. Only points in one direction in the x, only one in the y. Then these go all the way up and all the way down, except they're missing 1 point, and they're missing 1 point. So these will not work either. This one definitely wouldn't, because this one only points in one direction. So we're stuck with the cubic family. So I'm going to now name this. This is part of the cubics. And then do we have any shift? You could shift if you wanted to. You could do a stretch if you wanted to. It's not going to change the fact that a cubic goes all the way up and all the way down. So I'm going to use the easiest equation possible and just use x cubed. If you want to apply a shift, go for it. All right, let's take a look at the next one. So I'm going to first sketch the domain and range. I think I want to capitalize these. Domain and range. Okay, so we sketched. Well, we haven't sketched yet. So this is going to be a graph that goes all the way left and all the way right, because my domain, which is x, goes all the negative infinity to infinity. My range starts at 2, included, and it only goes up. So I want to draw this with a closed circle at about what I'm considering a height of 2, and only goes in one direction. So now let's go to our function families and find a function that goes all the way left and right, but only points either up or down. Well, we've got a couple of them here. Now, these two, right away, we can pick those. Those point only up. This point's only up. This point's only up. But why can't we use this one? Because this also only points forward. See what I'm saying? Remember, our domain was negative infinity to infinity. So we need a graph that goes left and right, as well as only points in one direction. So I could use this guy or I could use this guy. It doesn't matter which one. You pick. You pick. I'm going to choose to do absolute value this time. I don't know why. I just want to. So my function family is absolute value. Is the shift, do I need any negatives? Nope, I'm pointed up, and that's the same as what my function family does. The absolute value function family points towards the positive y's, and my range is going towards the positive y's. But I do have to shift it up. I have to shift it up 2 spots. So if we go back to this sheet, if I'm going to shift up in the y direction, that's going to affect my function only on the end. So I've got to make sure that I do a shift on the end of my absolute graph. So our equation could be take the absolute x, and then I want to shift it up 2. Notice I didn't put the plus 2 inside of the absolute value, because that would have shifted it left and right. We want to shift it up in the y direction. Okay, hopefully that's making some sense here. If not, we're going to keep going. Well, we're going to keep going either way. But so next up, let's take a look at our domain and range. I'm going to encourage you to try to sketch this. If you haven't paused, pause. All right, let's see how you did. So my domain starts at negative 2 and only goes forward. So I want to include and only go forward. My range, now this is interesting. My range starts at negative infinity and goes up to 3. So I'm going to reach a height of 3, and I'm going to point down from there. Or you could go down and then move your way up if you wanted to. Either way is fine. So I need a function family. This one's really easy to me because this I know right away. There's only one function family that points only one direction on the x. This goes left and right. This goes left and right. This goes left and right. This goes only right. So I know it has to be the square root family. This goes left and right. This goes left and right. So I love the ones that go only one direction in the x because it has to be the square root family. Okay, do we need to put any shifts or do we need any negatives on there? Let me identify first. This is the square root family. Now, do we need to apply any negatives? Yes, because this graph, the range needs to be pointed down, and the function family square root normally wants to go up. We got to flip that, so that I need a negative out in front. If you want to put a stretch in here, you can. I mean, it's not going to, if your graph already points down, stretching it downward isn't going to make it go down any faster. So you can do it or not. Now I need to apply 2 shifts here. I need to shift backwards 2 on the x. So remember, any shift in the x direction actually does the opposite. And then I need to shift my graph up 3 so that it'll reach a height of 3 for my range. Here's my function. I think we might be getting to the spot where you can try to do these next 2 on your own. So I would encourage you to pause here. As always, I'll never know if you did actually pause. But if you want to get that practice in instead of just watching me do math, I would recommend it. Okay, let's see how you did. So my domain stretches all the way. My range starts at negative infinity and goes up until 4. So I got to find a function family that goes all the way left and right and only points in one direction. This time I'm going to choose to do the quadratic family. I could have also chosen the absolute value family, but those are the only 2. You couldn't have done any of the other ones because your square root only points in one direction, but it only for y, but it also only points in one direction for x, so that wouldn't work. Okay, do I need to do a shift? Yes. And do I need a negative? Yes, because a quadratic normally points up. We need ours to point down. So I'm going to put a negative out in front. I'm not going to put any shift on the x. Now, I like to still include my parentheses. It reminds me that I'm not shifting in the x direction, but I do need to shift up 4. So I'm going to put a plus 4 at the end there. And then let's see how you did on the last one. Get organized here with my colors. Move the ones that I've already done out of the way so I don't repeat, for shame. All right, let's see here. So my domain is from 1 until infinity. So it starts at 1 and goes to positive infinity. My range starts at negative 4 and goes up to positive infinity. So I need a graph that only points one direction for domain. Game over. I know what that is. That's a square root again. So this is the square root family. This time my range is pointed upward, just like the parent function, so I don't need to shift. Sorry, I don't need to reflect. I do need to shift, though. I need to shift forward on the x. That's going to be an x minus 1. And I need to shift down in the y, so that's going to be a subtract 4 at the end. Okay, hopefully that was pretty clear. We haven't, if you notice, we haven't talked, though, yet. We've done everything on the front. We haven't talked much about reciprocals and reciprocals squared. So notice, in the domain here, as I go left and right, all these x's are covered. See how this graph hits every one of these x values except for this x value. So this is a situation where every x value, everything in your domain is covered except for 1 point. And then from my range point of view, everything in my range is covered except for 1 point, this 1 point right here. Now, when it comes to reciprocal squared, we've got the same issue with x because all these x's are hit. X is hit, x is hit, x is hit, and then we have an asymptote. So this one x value is missing when it comes to range, and then all these x's are hit. When it comes to range, though, we're missing this value, but it's only pointed in one direction. Like over here, you're missing one value, but you're still going up and down. Your graph is still going up and down all together. This graph only points upward. So this is going to look a little bit different, and we'll talk about that when we get to those examples. So let's try to do a sketch. This is going to be a little bit tighter fit, so we're already writing pretty small. You're going to have to keep writing tiny. All right, so now my range, my domain, I'm sorry, is going to go all the way to negative 1, skip negative 1, and then keep going. So my range is going to look something like this. Open circle at negative 1 and keep going. My range, same thing, except the open circle is going to happen at 2. So it starts at negative infinity, it goes to a height of 2, and then it keeps going up from there. So I need a graph that is only missing 2 spots, but goes in every direction except for those 2 spots. So that's got to be the reciprocal family. Because remember, reciprocal family goes up and down, where the reciprocal squared only points in one direction. So I know this is going to be the reciprocal family. It's a weird looking R. Do I need to shift? Yes, I need to shift back 1 and I need to shift up 2. So that's going to look like 1 over. And I'm going to put my shift on the x, so that's plus 1 because it does the opposite. And I need to do a plus 2 to shift it up 2. All right, let's try another one and see what you think about this. So here I am again, writing really small. My domain, left and right, and misses at -2. Range starts at 2, but doesn't get included. Do you see the difference here and here? Here's a graph that starts at -4. We included that because it's a bracket. Here's a graph that starts at 2, and we don't include it because it's an open circle. So I've got an open circle at 2, and it only goes up. This is what reciprocal squared looks like. That's reciprocal squared because, remember, reciprocal squared only goes in one direction, where reciprocal goes up and down. Okay, so I've got to put a shift on. I don't need any negatives because we're pointed up. So I can do 1 over. My shift in x is -2, so that's going to look like a +2 in the equation. I need the squared. And then I need to shift up 2. Okay, so at this point, we've covered them all. You should be able to do these last 4 on your own. So I would encourage you to pause, maybe turn it back on to see how you did after you do each one, but try to do these next ones on your own and try not to wait for me to do it for you. Okay, let's see how you did. So I'm missing 3. My graph starts at -infinity and goes up to -1 and doesn't get included. All right, that's reciprocal squared. This time, though, I do have a negative because my graph, reciprocal squared family, likes to point upward. Unfortunately, our range points downward. So we want to definitely include a negative. So I would have -1 over, and then I've got to do my shifts. So this shifted forward 3. So in my equation, it's going to be x minus 3. And then my graph shifted down 1, so that's going to be a subtract 1. And yet again, if you haven't done it yet, I encourage you to pause here and try to do these on your own. So this one starts at -1. It is included. Goes forward. Starts at -infinity and goes up to 1. That is included. Like I said, these are the easy ones. When your x values only, when your domain only goes in one direction, it's automatically got to be square root. Do I need a negative? Yes. My domain, my range is pointed downward. So I need to reflect that graph. I need to shift the x, so that's going to be x plus 1. And then it's also going to shift up 1, so that's plus 1 plus 1. I did this wrong in my notes over here. Holy cow. This is right now, I think. Let me know if it's not. What do we got left? I got 2 more. Domain. It's missing 1. Jeez, didn't give myself much room there. From -infinity up to 2. Not included. So that's right away. That's got to be reciprocal squared again. I do need to reflect it again, just like we did in the orange example. My shift is forward 1, so that's going to look like a -1. This is a up 2. And then finally, let's do, what an ugly brown. Domain, all the way left and all the way right. range, negative infinity up until 3, but included. So what's a family that goes all the way left and all the way right, but only points up or down? You could pick absolute value or quadratic. I feel like doing absolute value again. You could have done quadratic. I do need a negative because our range is pointed down. I don't need to shift in the X. If you want to, you can. You could put a shift on here, but if your graph already goes all the way left and all the way right, shifting it in the X direction will not change that. It'll still go left and right. So if I move something that goes all the way left and all the way right, if I move it 3 to the right, it's not going to change that it goes all the way left and all the way right. So I'm not going to put any shift on the X. I must put this shift, though, on the Y because my graph needs to reach a range height of 3. All right, hopefully that makes more sense than it did when we first started. But like I said, if you're struggling with what we did back in 1.6 or 1.8, go back and look at those again before you try to do this, because you got to understand that. I think I would guess before you can do this.